Dispersal and range expansion. How do organisms expand where their distribution is, and how do they form new populations? List different methods of dispersal. Relate these to life histories with each organism. Relate geographic range limits to, of course, climate change, and relate dispersal to range expansions. Both topics here. And list and define dispersal patterns in streams. How do fish get past waterfalls? So, populations. Seems like a sensible space to start. Is it too crowded? Do we need to move somewhere else? The population dynamics is a field of measuring rates of population growth. The logistic, the exponential growth, covered in a different lecture. One thing that is covered is N, the number of organisms, versus K, the carrying capacity. If N is greater than K, then emigration, the departure from a place, is required. Many organisms actually have a phase in their lives that this can be done during that certain specific phase. So how do we know if N is too great? Well, there's an equation for this. Yay, math! So we have the births plus immigration. So births plus immigration, these are both positives that will increase N, minus, because it's always a negative number, minus deaths, and minus emigration is these are both going to be negatives of things leaving, and starting with, of course, your N at t minus 1 equals your N. So the total number is going to be equal to the births plus the immigration, minus those that leave by death, minus those that leave by emigration, plus the initial number in the last generation. It can be just read as Biden. And that's not a promotional thing, that's just more likely to make you remember it. So there we go. And that's how we determine what the current population is. And if that current population is greater than some carrying ability, then emigration is needed and there will be dispersal. So there are costs and benefits to a dispersal phase. If an organism is doing well where it is, there's really only costs. But there can be some benefits to the organism's offspring. A benefit would be that an immigration actually introduces new genes and can cause gene flow, reducing the chances of genetic drift. We'll get to that a little later. Benefit is colonizing new environments. So an organism that disperses well is going to seek out brave new lands. And there's also reduced competition when there is dispersal, because carrying capacity is often defined by the amount of organisms that, can survive in an area. They will have to compete with each other to survive. So leaving that area to an area with fewer organisms is a reduction in competition, inherently. Some costs. If there is gene flow, there can be local adaptations which are lost. So there could be new genes coming into a population that actually reduce the fitness. I should say new alleles coming into a population that actually reduce the fitness because those alleles are not locally adapted. There is a cost to dispersal, and that's many organisms will not find suitable habitat. Consider, if you will, a shelf fungus that grows only on, let's say, dogwood trees. It will release billions of spores during its lifetime. And how many of those spores are going to find a dogwood tree? Well, very small number. How many of those spores are going to find a dogwood tree they can infect? Even smaller numbers. So one cost of dispersal is a massive death rate. And that's often death during the journey. So there's predation, there's starvation, there are various other cases like being blown up into a thunderstorm and hit by lightning. I mean, there's a whole bunch of different ways that an organism can die during the dispersal phase. So how does this happen? So let's think about some methods. Wind dispersal, of course, can get from pretty long distances. There's sea dispersal, where the tides and in the plankton. And there can be dispersal of the whole organism at one stage or the whole organism at a different stage. There is also dispersal of gametes. Just remember that that does count as gene dispersal, not organism dispersal. So the movement of pollen is a gene dispersal event. It's a gamete dispersal. And we're really not covering that here. It's only half an organism. So why do many organisms disperse when they're young? Well, they have their whole life ahead of them, generally because they're smaller. And consider also the benefits of a sedentary stage. So some benefits may include being able to grow very large and not move if it's a good environment, outcompeting others. So in sedentary stages that can release repeated bursts of dispersal stages can colonize a lot of environments from the safety of their home. So I want to kind of take you guys, so adaptations. Let's think of some methods of dispersal. I want to do this kind of as a group, but in the absence of a group, I'm just going to take you guys out to where I have a whole bunch of things trying to disperse. Let's head out to the garden. Welcome to a rather seedy place, my garden. As we have here, we have a bunch of plants that are currently trying to move somewhere else to kind of disperse. And we've actually got a bunch of good examples of plants that are trying to move their seeds around and how they can do this. First up, we actually have the lettuce plant right here. These are lettuce seeds. They're attached to little puffs here. So make a wish, right? And those will catch on the wind and they'll disperse pretty much as far as the wind is blowing that day. I actually shake these out every year on my garden so that lettuce will just kind of grow there and volunteer. Another example of wind dispersed plants is this poppy. Yes, it's that type. And what happens is as wind hits it, it'll lose seeds. There you go, kind of like that. I put poppy seeds in my cooking, so I use it for those purposes, but it will just shake all over the garden. Now, these are very small seeds, and wind dispersed is good, but what if we can give it a little more oomph? And that would be the California poppy. These have what's called explosive dehiscence. So when they reach maturity, they shatter and they fire their seeds everywhere. I've planted California poppy in my front garden, and it has been exploding for about a month. So it's moving around. Also, you can catch the wind. The maple tree. Caught it a little late. Throw it up, and it's over there now. May or may not have caught it in action there, but that's called a samurai schizocarp. That's the actual name for the dispersal technique there. Now, the problem with catching the wind is that you have to be very, very light. And if you're a very light seed, then you don't have a good start in life. So the poppies in my garden start out very small, and it would be advantageous if they could start a little bigger. But these bigger seeds, here we have a buckwheat, less likely to be wind dispersed. They're a little too heavy for that to go very far. Yes, I'm just throwing random seeds in my garden. So these buckwheat seeds won't go as far, but they'll have a better start in life. There's also the possibility of moving bigger seeds by hiring something else, and that's what I've got behind me. This is my son's tomato plant here, and that tomato plant is going to get good ripe berries, red berries, which are going to attract birds to kind of move it around. So we also have the bird dispersal. I would assume that these squash plants down there would be dispersed by other large mammals that would digest the squash and pass the seeds along. There's also the option of just moving the whole plant, a clone of your plant. I have some lilies out front, and the lilies will produce little bulblets. Those little bulblets are a clone of the plant, and can be, when the lily falls in the fall, it gets a whole line of bulblets there, which can also be dispersed by the movement of rainwater and push them down, or just any soil movement, really. And as a more extreme measurement, there would be potatoes, which just plant themselves in the soil, and they don't move as far, but being a larger lump, they can have a bigger start in life. So you see a trade-off here between the smallest of seeds, which can just be moved by the wind, and the bigger seeds, which can be moved by animals, and the bigger clones or bulbs, which just get moved, which just stay close. So there is a trade-off inherent in dispersal when it comes to seeds. That was kind of fun. I imagine that you could probably ask me for some of those lettuce seeds, buckwheat seeds, and poppy seeds. I'd be happy to share my plants, and that's actually my fallow mix. So I actually throw all those seeds back into the garden, and then if I'm not farming in a certain area that year, then those seeds will just germinate, and I'll just have a crop of lettuce, poppies, and buckwheat. The buckwheat is just really for decoration and bees. It's not a very useful plant. I like how it looks, though. But yeah, I can always throw you my fallow mix. If I'm not going to send it to anyone, though, there seems to be some problems with sending seeds in the mail. It's not a good idea. So animals and fungi, though, I mean, you see these bison ballooning. That doesn't actually happen, but we have spiders around our house, a lot of those garden spiders, and they'll put the little silken webs up and kind of balloon away. We have squirrels fighting out there today, and they'll chase their young away. So that's their dispersal phase, is just migrating. For fungi, you can think of their spore phase, borne by the wind. The wind is a great method of dispersal, but it requires that you're relatively small. So seed size. Remember what I was saying in the garden, that larger seeds produce larger seedlings, but smaller seeds will travel further. And this is why we have such adaptations, such as the wings that you may have seen of that samurai schizocarp, the maple, the nuts that can be buried by the squirrel. We don't have any nuts around here. And the fruit, such as that tomato, that can be eaten. Here's another example. This is Viscum album. It's a mistletoe. And the mistletoe produces small white berries. Now, these white berries are edible to birds. It's called album because they're, well, white. It's called viscum because the berries actually produce a viscous fluid inside the birds. So that when they come out, they stick to the bird's bottom. Because it doesn't suit a mistletoe to just land on the forest floor. Mistletoe are parasitic, and they are parasitic on tree branches. So how does a mistletoe move its seed to another tree branch? Well, sticking to a bird's bottom is good because the bird is going to have to wipe its bottom off on a branch. And when it wipes its bottom off on a branch, that viscous fluid that stuck to the bird's bottom is now stuck to the branch, which sticks a mistletoe seed to a branch, its host. And that's how mistletoe specializes in moving from branch to branch via bird bottoms. Dispersal can also lead to range expansions. So one example would just be, you saw those wind-borne lettuce seeds. Well, my neighbor has a lot of seeds that are related to lettuce called cat's ear or dandelion. They disperse in the same way, and they're constantly dispersing into my lawn. So it works. It expands their population, and they all die here. I kill them. But it's a lot of work. Anyway, young doves. There's the Eurasian collared dove. They either expand a little or a lot. So some young doves will actually fly a good distance. Some young doves will only fly a block or two away from their nest. In Europe, there's actually been an expansion going on from Turkey on up since about 1900. In America, these doves were introduced into, I think it was Florida. The map will show you. And they've been expanding since the 1980s. So they are kind of moving just about everywhere around here. They do exist around here, and they actually have come to my neighborhood. We have Eurasian collared doves in my neighborhood now, and they have dispersed by that kind of expanding their population size and expanding their range based on how much the young disperse. So, on that as well, there are toads in Australia And it turns out that there is natural selection for some of them to actually have longer legs and a greater jumping speed because that allows them to disperse even farther. I actually do want to go back to that to discuss tree dispersal. Range expansion and dispersal are linked. As I mentioned with the toads and I mentioned with the doves, the differences in how much they disperse can give fitness advantages. We can also trace how long it takes things to expand after a niche expansion. So if you were to look at that maple seed that I had, you saw how it started to fall, but it spun as it fell. Well, consider the height of a maple tree, and then consider the amount of wind, and you can actually predict how far a maple seed can go. So they're not going to go high up in the stratosphere unless there's really, really windy weather. They're relatively heavy, actually. So that's how far a maple seed can go in one generation. So every year, a tree will send out its seeds, say a maximum of 1/10 of a kilometer. And that 1/10 of a kilometer is where the next generation can form. And that tree has to now grow to maturity, and then it can move its seeds 1/10 of a kilometer. So you essentially have 1/10 of a kilometer per generation, if that's how far the seeds can go. And after a glacier retreats, then the trees can follow it based on how fast they can move their seeds. You compare that with a failure, such as the Osage orange. An Osage orange is, look it up, you've got internet. It's not what you expected, is it? So those things don't have a North American mammal, or any animal, that will eat them. But it turns out, yeah, horses will, and I believe elephants do. It's hypothetical, question marks. So they didn't move. They could just, those big fruit would just land on the ground and roll and have a very low seed regeneration. So they only really were found in and around Osage County, Texas. There were some in the Ozarks, but what is their potential range? Spread everywhere. Spread everywhere in North America. And it turns out that they make very good, fast-growing windbreaks. So during the Depression and during the Dust Bowl times, farmers would actually put these Osage oranges as hedges. So during that time, Osage orange went from this small, isolated population in Osage County, Texas, to everywhere from Nebraska to Maine. So all the way from Louisiana up through, I don't know if there are any in North Dakota, but really wouldn't surprise me. So they expanded greatly once they had something that could help seed dispersal. So that really aided in their expansion. But really, their population was limited. Their range was limited by the lack of dispersal. Climate change leads to dispersal as well. So mosquitoes move north, but they tend to die during winter freezes. Severe winter freezes will kill mosquitoes. So that was that's a problem. But as we lose severe winter freezes, it's believed that this Aedes albopictus, a type of mosquito that transmits deadly viruses, will be moving northward and will be colonizing places like Buffalo, New York, if there is an increase in the temperature, which can mean that things like dengue, yellow fever, West Nile virus can start moving north with their vectors. Oh, joy, we get to enjoy guinea worm here in Washington. Not really, but you have to wonder, how far north can things move? How far north will things move? And yeah, not very happy. I've already given examples of trees for the Osage orange and the maple. You can look back at a different lecture to see examples of spruce at the end of the Ice Age. Realistically, this is the concept with niche too. As the niche expands, the range expands at the rate they can disperse. But not all ranges expand. Mountain populations actually decrease with climate change if they are adapted to this. You got a mountain here. If the range here of this organism is limited to up here, but climate changes then that range decreases. And eventually, if that range decreases enough, there's simply no place for it unless they find some higher mountain somewhere else. But eventually, oxygen will become a factor. So this is also not always true about island populations, as islands might shrink. The advance of desertification in Africa actually contracts some ranges. So it really comes down to, as well, the rate of change versus the rate of expansion. So if the climate is changing faster than the organism can move, let's say you have North America here, Florida is really currently North America. There's some Great Lakes, whatever. The east coast of North America, if you've got a range of an organism, it'll have to move north faster than the climate changes. So if the climate changes where the temperatures here become the temperatures up here before the organism can move that far, then it just goes extinct. It can't adapt, it can't move fast enough. And this is actually why there are people out there who are literally driving seeds north. So there are actually people who are bringing seeds from Oregon and seeds from California up here to Washington, because the climate is changing faster than those seeds would get here naturally. And what type of seeds? That would be Douglas fir. So the trees down there like hotter climates. And as we get hotter here, they'll do better. Last, streams. Downstream is an obvious way of dispersal. Things move downstream. There's actually we're tracking this in the Hoh rainforest, in the Hoh River. There are people who introduced gravel to the Hoh River, and that gravel was full of Scotch broom seeds. Now we can actually track the Scotch broom population as it moves downstream, gets eliminated by the 10,000 Years Organization, and then they'll find more seeds downstream, they'll eliminate it, and they'll find more seeds downstream, and the population is basically washing out. And one way that occurs is during spates, which is a flash flood. Moves things downstream in a hurry. There's also drift, which moves things downstream at the regular rate. What about colonization of new rivers? And how do fish get to new ponds? This bothered me when I was living in upstate New York. Cascadilla Creek had a lot of waterfalls, and you'd find these little minnows in upstream ponds, and I couldn't figure it out. How did the minnows get upstream? They can't swim up the waterfalls. And someone said to me, well, they swim up the waterfalls when the waterfalls aren't waterfalls, but are floods. And that worked for me for a moment, because Cascadilla Creek gets torrid enough that you could, if you're strong enough, swim just right over the waterfall when it is just a huge current of water. But then I realized that the water is flowing faster then. It's much harder. So it's still the same slope, but against a faster force. So I asked around, and people didn't know. Someone said, okay, well, actually, it's when the fish are being caught by a bird, and the bird drops them in a different pond. Well, that seemed likely until I realized that most birds don't carry fish long distances. But they just eat them there. They're the nearest tree. So that doesn't really work. Then finally, a study came out that showed about how adhesive fish eggs are to duck feet. That made a lot more sense. And that's the current hypothesis I'm going with, that the fish eggs adhere to duck feet and that the ducks move. So they are still carried by birds, just not on purpose. Of course, here in Washington, we have dams that actually prevent the upstream movement of salmon. And we have a most entertaining way of ensuring that the dispersal of salmon is not restricted. It's called a fish cannon. Go look that up.